Hello, everyone. It's Patrick Kofi Austin. It's Monday night, and once again, it's another Makers Monday. I am broadcasting from my home this time instead of from the MatchBOX. But James, of course, is with us. How you doing there, James?
Good, good. I'm just enjoying your background there. It's fun to see your new house, I guess. But yeah, welcome everybody. It's Monday. I would be remiss if I didn't say. I'd be lying, I guess, if I didn't say I am pumped. I'm excited that it's Monday. This is literally one of my favorite things to be able to do. We've been doing this for almost 2 years now. I was looking at the calendar. Kofi, you and I have been doing this for a while. Um, Along with that, I want to make sure that everybody knows that we are in downtown Lafayette, Indiana, at the MatchBOX Makerspace. It's part of MatchBOX Co-working Studio. Please come down and say hi. I'm here in the afternoons during the week, and I'm here by appointment. And then, in general, if you have any questions about the Makerspace or making in general, please let me know. Also, if you're watching, feel free to throw comments and questions in the chat. We'll address them as we go. But tonight we have a great guest, Cameron. Cameron, tell us about yourself and what you do.
Hi, Patrick. Hi, James. It's nice to be on. Thanks for having me. So my name is Cameron Smith. I'm the CEO and Chief Engineer of PantherWorks Warfighter Fabrication. We make weapons and defense articles for the government, for dealers and consumers around the Midwest. And we also have been a job shop, parts shop. I've got a background as a consulting engineer. I have been involved in systems engineering, industrial engineering, electrical, mechanical, product design. I've got a pretty broad experience base. I've been in the industry for quite some time. And as a consulting engineer, you get to see a lot of different things. So one of the things that's most enjoyable is doing a bunch of engagements and getting to see how different people solve different problems that are really similar. So that's kind of what I do. That's who I am. And that's my background. On my day-to-day, nothing too terribly exciting. I spend a lot of time doing parts design, product design, testing, and solving manufacturing strategy problems.
Nothing too cool at all. But
I was thinking the same thing.
I just come up with cool stuff every day that people use every day and build and make. Like no big deal.
Yeah, well, so that's the weird thing, right? Is the language that we use to talk about stuff. One of the things that I find that's absolutely wild to me is that you can have people who find what they do to be incredibly mundane, and that's their day-to-day job, right? And then I'm also reminded of like a piece of writing that Neil Armstrong, of all people, put out, where he was at a party and he had imposter syndrome and felt like he wasn't, important enough to be in the room. I'm like, you're Neil Armstrong. Like, you could be in any room you want to be. I'm not certain that anyone can tell you can't be there. And so like those are the kinds of things where like I think it's very intrinsic to our human experience is when we find something that we do on the day-to-day that's, maybe kind of a little mundane. I'm like, on Monday, I'm checking my emails. I'm trying to figure out what's going on. And then an hour later, I could be in the shop programming an industrial robot or a milling center or something. And then an hour after that, I could be on a weapons range doing test fires or something like that. So it's, to me, those are very like normal things. And so some people, they get a little numb to what they do. And I always want to try to be grateful for the experiences I've been afforded, both by my clients and then also directly working for myself.
Yeah. So you touched on a couple of really important things. I have so many questions. But one, I find this to be true for myself and a lot of people that I talk to on here, is that if you have a job that you're able to like switch around every 20 minutes to an hour, and you're able to like get up and walk around, you're able to, you might be doing computer screen stuff and then be able to get up and walk over and do some other things, and not just get up and walk around, but actually just change your entire mindset of what you're doing. It's been proven that you can work longer and a lot of times more efficiently like during that time, but you also can work for like 10 hours and not really know, right? Because you've been changing around your stuff. That's how we're programmed to like function. So that was a great point that you just like brought up. And I'd like to like mention that we've heard that a lot of times, and I hear that when I talk to a lot of different makers. But more on you, all on you. How did you get into this? Like, what's that origin story? How do you like you're a CEO and then you also do a bunch of cool stuff. So how'd you get into it?
Well, I mean, so if you go back and you look, right, the path of most people doesn't tend to be a super straight line. Like, I mean, I've got friends, I've got family. I know a guy, a good buddy of mine. He knew he wanted to be a doctor since he was in 5th grade, which is weird as hell to me. But literally graduated high school, entered pre-med, finished pre-med, went to med school, finished med school, did his residency, finished residency, did his specialty, graduated, boom. Guy was 29 years old, board certified doctor in his specialty, right? Like he had a jetpack on A to B. And then there's the other 99% of us where it's like, I'm really glad that worked out for you. And society is super well set up for people that have their entire career trajectory plotted out and they can spend 20 years doing that. But for me, it's been a much more meandering, wandering path. And I think that to answer the question, it changes depending on which part of what I do are you talking about. So how did I get started being an engineer? How did I get started as a weapons designer? How did I get started as a maker?
Let's try at least the first two.
Okay.
Right? Like, how did you get started as an engineer, and then how did you get started in the weapons making, and then also as a CEO? Like, how'd that happen?
Right. So I'm a 4th generation engineer. So I like most things, right? It's a family vocation. My mom and dad are both engineers. Their parents are engineers, right? I am a 4th generation engineer. My kid wants to be an engineer. So it's one of those things that's really wild because when you ask engineers what they do, you get one of two answers. You either get these hyper detailed analytical answers, or you get some like very silly BS answer that's like, oh, engineering is just what engineers do. And so my parents were very good about showing me a wide spectrum of engineering. My dad, in particular, his specialty is what we call systems engineering, which is a multidisciplinary engineering field where you combine industrial, electrical, and mechanical disciplines to solve novel problems using technology that meets or exceeds the current state of the art. So I grew up watching my dad do that. I'm like 10 years old, 11 years old. My dad worked at AT&T Bell Labs in the 80s. And it's like, oh, like the coolest research place on the planet, like billions of dollars in the 80s for research and development, and just making some cool stuff, working on stuff that goes on spaceships, working on stuff that goes in the bottom of the ocean, and just all kinds of cool stuff. And so like watching my parents do that grow up, and then my grandparents also doing that as well, it was like, okay, yeah, this is your job doesn't suck. That's pretty cool. I'm here for it.
Yeah.
So that was how I really got my start as an engineer, is watching my parents and just being interested in that. And what you see in a lot of engineers is that it's a philosophy far less than it is a specific education. There's definitely an educational component, and you have to understand your industry and your discipline. And most importantly, you have to understand your application and expected outcomes. But more importantly is like you just have to approach things with a certain philosophy of understanding. I want to seek to understand what the outcome is. Once I know what the desired outcome is, I can look at the things that are required to achieve that outcome and work backwards from there. Even if we were to sit down right now on the stream and we were to invent a new thing, we could sit down and we can come up with, all right, here's the chief stakeholder. What are the client requirements? What are the system requirements? What are the environmental requirements? NASA actually has a beautiful V-shaped model for systems engineering. And so when you look at like some of those things, like it's very philosophical in a way, which is strange because a lot of engineers wind up being very analytical. And of course, the old show engineers have crap people skills. So I watched my dad do that, watched my mom do that, watched my grandparents do that. And I was like, you guys have really cool jobs. I want that job. And my parents also, when they got out of industry, they decided to teach. And so my mom and dad, in a very interesting twist of fate, decided that high school was going to be a waste of my time. And they enrolled me in college when I was 13 after a year of homeschooling.
Oh, wow.
And so I graduated when I was 16 with my associate's degree in electrical engineering. And then after that, got onto this meandering path where I did some component and systems level stuff. I did some automation applications, which got me really interested in industrial work. And then in doing more industrial work, I got really interested in mechanical work, went back to school, got a good education in mechanical engineering, GD&T, design principles, and mechanics, statistics, took way too much math, thermodynamics, which is fucking awful. Oh my God, guys, it's just so tragic. I got a buddy who's going through right now. He's at Purdue for mechanical, and he is just so stapled down in math. I was like, it gets better. I promise you'll get to work on cool stuff. You just have to graduate.
You got to make it through it, right? You got to get there.
So that's where the educational background comes from. But the challenge is most of my career, I did on an associate's degree. And a lot of people say, oh, Cameron, you didn't get a BS in engineering from a A school. Like, no, you figured that out. Like, you worked on your own, or you did this. It's like everybody has their own path. I mean, there are lots of people who will sit down and they'll plow through and they'll get a master's in engineering, and then they can't get hired anywhere. You have all of this wonderful theoretical knowledge, but man, there is nothing out there with your name on it. And now, especially now in this economy, people are demanding $100,000 or $150,000 for an engineering position. I'm like, I can't trust you to talk to the client, let alone you to demand that salary.
Yeah, because you're now in the position that you're hiring engineers.
Right.
Right. So then, that's actually something I want to get into. Like, what are you looking for when it comes down to like hiring an engineer? So sorry,
No, absolutely. Well, I mean, we're talking about backgrounds and qualifications.
Yeah.
Well, I'm going to say one thing. You're now officially the 5th person I know that skipped college. So, skipped high school, which is
high school. Yeah, that's crazy to me. Like,
well,
awesome.
I mean, education reforms are super necessary. I feel like we wind up spending a lot of money on what is essentially making sure our kids are okay and don't commit crimes while we're at work. They're adults, and then they can be held accountable for whatever they do during the day.
So true.
And I mean, it's like, but there are also like really important things. Some of the things that I missed by skipping high school, I really missed socialization. I really missed having a cohort of my peers. I missed traditional social activities. And we can argue whether that's super developmental or not, but I exchanged those for an advance on my education. Right.
Yeah, totally.
And so what happened? Like, my first employment contract, my dad had to sign. I was 16. Like, did I really get anything for that? Like, I mean, it's cool. You can design a bridge rectifier circuit, but like, you should also probably learn how to talk to people.
It's cool. It's probably not for everyone, but luckily you figured out how to talk to people.
Well,
right? Like that, you figured that part out on, and you and I have hung out outside of work a couple of times, and you're a pretty friendly person. So that's good. You figured that out.
Oh, make it a girl.
Right?
Watch.
Yeah, that's exactly what I'm doing.
Fortunately, it's something that I happen to have a natural aptitude for. I love talking to people. I'm very extroverted. Mm-hmm. I actually have one of the best facets of my job is actually sales engineering, where I can engage a client, talk to them about what their needs are and what they want, where they are, look at that like green field, green pasture that they imagine is the outcome of whatever they're at, and then listen with consulting ears, listen to their pain points and try to solve the problem for them. And the more technical the problem is, the easier it is to talk to people about the problem in a non-technical way. So what happens is somebody might get really in the weeds about a particular part holding up for a certain number of cycles or for a certain duration or for X, Y, or Z. And I try to go back even farther than that and just say, hey, what do you want? Like, if you could snap your fingers and get the top 3 things on your wish list, what would they be? And very rarely have I had a client ask me, I want 13.5% more cycle time.
Yeah, that's typically not what people are doing. Yeah, and
not how human beings work.
Mm-hmm.
So it's one of those things where, like, what I do find is I find people that say things like, well, I would like to be able to increase the productivity that I have for my operators. I want my operators to be more productive on the time they're here. And I say, okay, cool. That's an actionable thing, right? That's a very action-oriented bullet point. as opposed to, I want the cycle time to be 13.5% faster, right? It's like, oh, I want my operators to be able to make more in their shift. Okay, cool. So I don't know whether I can get you 13 or 30 or some number in between, right? But like, we can look at those metrics and try to hit those and change those things. And then again, too, this is all consulting work before I even worked at the firm I'm at now. And so it's very much about wanting to achieve outcomes for people, right? And that transcends, like, that's not even engineering at that point. That's just problem solving, which I think is the foundational skill for professional services.
And that's likely something that, like, your parents, as both engineers and teachers, likely taught you with problem solving skills when you were growing up. So that makes a lot of sense.
It is the fundamental skill.
Yeah. And going back to your thing about now, so now tell us how you got into the CEO position, or how you started your own company, I guess.
Well, consulting engineers aren't paid very poorly. And so I had some money saved up and was trying to figure out what to do. COVID hit and I was traveling, 30, 40 weeks a year and stuff. And it's like, you know what? I don't want to do that anymore. I can't do that anymore. Right. So instead, I was like, all right, well, maybe I'll open something up here, or I'll do something here that's a little bit more straightforward or easy, not travel as much. And I met some folks out at the range who were very interested in working together, and they had an interest in this shared hobby. Right, we're all shooters, and we enjoyed sporting firearms, and had military backgrounds. Right, half of us were vets, and so it's just like, okay, cool. Like, this is really neat. Here's a group of people that's motivated and interested, but what they don't really have is somebody that has the business acumen or the background to translate their desire into a functioning business. And so as a consultant, like, one of the first things that I deal with from pretty much any client is, how does this integrate with your business? How does this integrate with your value stream? How is this a revenue generating activity for you? What part of the business is this? Is it a process fix? Is it a technology fix? Is it a people fix? All businesses are comprised of just three things, right? People, processes, and technology. They're all fundamentally boiled down to those three things. I usually have some technology that's often gatekept by cost or expense. I will build processes around them, and then I will find the right people to fulfill those processes, whatever they are. And we can look at just about any business and break them down into these fundamental building blocks. And so as a consultant, what you'll often do is you'll wander in and someone will say, well, I just bought all this technology and I want it to solve this problem. Say, oh, okay, well, not what I would have done first.
Yeah, totally went backwards.
Yeah,
exactly. I mean, there's one guy, I had a client, I basically told him, I was like, man, I think you would have probably been better off by just setting that pile of cash on your desk and just setting it on fire. You can't use any of the, 7 figures worth of stuff too. Like, you just can't use any of this. You don't have the people. We've got to go hire a half dozen people. Like, I just don't. Sorry, buddy.
Yeah.
So anyways, I saw people that were motivated.
Okay.
And they understood the processes that they used in other organizations, right? So had a guy who was a machinist, right? Mm-hmm. Had a guy who was a drill sergeant, U.S. Army infantry veteran. Had a guy who worked in IT and had some operations experience. And so I was like, okay, cool. I can knit these things together.
Yeah, you just happen to have the whole A team.
Yeah, literally, I collected the infinity stones of weapons.
Yeah.
And so it was one of those things where it was like, when it all came together, it was fantastic. And
cool.
Putting those people together in the same room, and again, too, like, that has nothing to do with engineering. Like, that was just listening to those people and saying, hey, here's an opportunity, here's some resources, here's something we could do. And that's one of the reasons why we took off and started working on the things that we've been working on, is that I just found some folks who wanted to do something different. They wanted to work for themselves. They wanted some freedom. They wanted some of the joie de vivre, right, that you get from working for yourself, and then realizing that you were probably the worst boss you could work for. That's why everybody likes to work for themselves. And they're
until you don't.
Freedom. And I'm like, cool.
Right.
Well, you're sick today. That's still not going to get done unless you do it.
Yeah, that's how it works.
Oh, that's fun.
So,
It's one of those things.
let me interrupt you again here. So you've been doing this, you said, since 2020, right? That's when
we started
formed the team.
right after. I stopped consulting when all the airports closed.
Okay, that makes
I did
sense.
a little bit of
You can't
follow-on work to close some projects out for clients, but I didn't take any new clients. A lot of them require on-sites, and it's like, I sure as hell not driving to California right now.
So you met all these people, all these guys, basically in 2020 or somewhere around there. You're probably friends with them before that, of course. But you formed your business 2020.
But most of them in 2020,
And now you're in Indianapolis, right?
We're in Southern Indiana.
Indiana, I'm sorry.
Bedford. It's about an hour and 15 minutes south of Indianapolis, right by Naval Surface Warfare Center Green.
Okay, cool. So it just happened to be kind of a perfect storm, and you saw your opportunity. You had your stuff set aside, so you're good. So tell us about, like, I guess, the hard parts and the lessons learned from starting your own company right then, and in the middle of a pandemic, really.
Starting something in the middle of a pandemic is definitely a challenge. What the biggest challenge that I had was, more than anything else, the supply chain is just hot garbage. The supply chain is just very, very, very painful. So what I wound up doing is trying to find something that I was able to do, right? And so that's when you start just running through ideas, right? Every business, especially a startup, like, people think that, like, businesses come out in their whole cloth, and they don't realize that this business actually started as this, and then became this, and this, and then became this, and then now they make cutlery. Right? Whereas someone might have gotten together and been like, hey, man, I know a lot about metal injection molding and casting. It's like, okay, well, you can make arbitrarily shaped parts out of metal, like, basically better than investment casting, great for complicated small parts, a fantastic manufacturing technology. But, like, what are you going to do? Like, how are you going to make this thing, And then how do you make it competitive with what's currently in the marketplace, right? And red ocean, blue ocean stuff. And so for us, I was like, what can I make? What's actually going to impact the industry? What's currently, what can people not get a hold of? What's out of stock? We're going to be a domestic manufacturer. I'm not going to have backlogs for international shipping, right? And particularly looking at doing principal manufacture from raw materials. So that's one of the biggest things that we really wanted to stick with. Is I was like, look, I got a guy that understands CNC. I can design parts. I got another guy that can make the logistics work. It's like, hey, we can put all of this stuff together. That's like, really what we need to do is, it's a quest to find the right product. I mean, with particularly like Vertical Milling Center, which is what we wound up with. Vertical Milling Center is essentially the tool you use to make all your other tools. Like, vertical milling centers are made on vertical milling centers.
Okay, so what you say when you say vertical milling center, that's the process that you decided to do, or the program?
Yeah. So vertical machining. So everybody thinks about machining, right? If they imagine in their head, or they Google search like machine shop, you see typically classic like J-head or like knee mills, and they've got these long tables, right? And there's a rotary tool that comes down and it does some work on a surface.
Right.
So that's a classic milling center, right? And so that classic mill, if we just put some encoders on some of those ball screws and we put some servos on them, and then we write some software, we can actually talk to it in a very clever way. Instead of having a human sit there and turn dials and turn those screws to move the table around and mill things out, it will just do it on its own because it's been programmed to. And so like the people think like the oldest like true machine tool is the lathe, right? From the turn of the 18th century. The French guy invented it. And that's where we're turning the work, right? The work is spinning and we take a stationary tool and we move the tool into the work. Here we're spinning the tool and the work is essentially moving into and around that tool. And so the process is so complicated. Right? It's not complicated. The process is fundamentally very simple, like most things. Like you can teach someone how to play chess in an hour. You can't teach them how to be good at it. And so it's one of those things where it's like you can very much make sure that almost any arbitrarily shaped part, if you're willing to do enough setups and move pieces around and make your operator's life hell, you can make just about anything on that machine. And even the factory where those machines are made, they make those machines, and then some of those machines go over to another line where they turn around and make parts for other machines that are also manufacturing. And so it's very, very common machine now in particular, right? And so that's where those particular tools, like when I was looking at it, like most machine shops, they wind up being either what we call turn shops or mill shops. Turn shops as in turning on a lathe, or mill shops as in they are milling things out. You do also get some shops that are wire shops, which are wire EDM. So they take electricity and eat away metal with very precise, very tight tolerance stuff. But
cool.
For the most part, most shops are either a turn shop or a mill shop. You do find some hybrids out there. Some shops are big enough; they got a guy for everything, right? It's like I got my lathe guy, I got my lathe guys, plural, right? My mill guys, plural. And there's also some super high speed stuff now where you've got some of these centers that are so complicated and so capable that they're 5, 6, 7 axes now.
Yeah.
It's not just one. It's not just milling anymore. They can actually take that part, and as it's affixed to something, they can put it in space, and then I could drive a lathe tool in it because I can also still spin it now that I'm holding in this orientation. And then once I'm done turning it, still without having to take the work out and re-index it, I can now turn that part and put it under a tooled spindle, and that tooled spindle now can come down and hit something. And so you can access from all kinds of angles. You've got really long taper tools that are really cool. And like a lot of that comes over from the injection molding industry, where you have to make these very large dies and mold bases. And so like those things are really cool. But when I looked at it, I'm like, I want the most flexible technology that we can afford, right? Like I don't have, the $1.5 billion. I'm not going to go out and buy a 6 axis like Doosan or something. Like that's not happening. Especially for a startup. I'm like,
for a startup. For what? So what did you end up going with?
So we went with Haas VF2 Super Speed. So Haas is kind of like the Toyota of milling machines. You usually see Haas and Hercos.
Okay. So how many people do you have working with you in your shop? Or machine operators, I guess.
6.
So 6. You're the main designer. Are there other people that do designs?
Yep, I do most of the parts design. My production engineer and lead machinist helps me sometimes with simple stuff. There are things where I'm like, man, that's a simple enough part. Like, you know your way around software well enough, you can draw it. And I mean, fundamentally too, it's about just a basic understanding of geometry. My 12-year-old draws parts. It's not difficult now. I remember the first thing I worked on was AutoCAD R14 back in 2002.
Yeah. Good old AutoCAD.
Did AutoCAD for a little while in like 2004. And it was not
wonderful.
Fun. I didn't like it.
Well, and that was at the time, that was before solid modeling. I mean, a lot of people use SolidWorks now, right? And it's that SolidWorks didn't come out until 2005, I think. And then I tell people that I wound up like I was actually drawing parts, before SolidWorks, before that solid modeling thing.
I remember doing the wireframe in AutoCAD, and it was awful.
Absolutely.
Excuse me just for a second, and something's about to fall.
So it was one of those things, like very ancient software, right? But like my mom was a mechanical engineer. She was like, hey, if you want to make stuff, you have to learn how to describe it with math. Yeah. I'm like, that's awful. Who wants to do that? She's like, well, we could also draw it in the software though. And I'm like, that is way more palatable.
That sounds a little bit more what I was thinking.
Well, and especially being a computer nerd growing up, and I was like, oh, you mean I can just like draw my parts instead of just try to understand like how parts work and represent parts like in isometric in a 2D space, right?
Right.
So, the challenges, like I said, have been quite numerous. I mean, starting during COVID was hard, but fundamentally we started with a very flexible manufacturing technology.
Yep.
Because with a mill, you can make especially like a good sized, competent mill, you can make almost any object, like any arbitrarily complex object. Not literally everything, but damn near if you're willing to take enough time.
Sure. But the key is to be able to make money doing it. So you need to be able to be efficient at it. And
Yes.
so that brings me to my next question, which is like one, seems like you had a team of people who all were in the shared common thing, but what else made you go into making weaponry?
Well, so I already own part of a range, and I've always worked around weapons myself, so the infantry myself, and always things that I felt passionately about, especially after carrying them around for a while. So you get used to, you have pretty strong opinions about how they should work and how they should function and things that you like versus what you were issued or had to use. And so I just found some guys that everybody was super excited about it. The market looked right. I mean, there was a period of time where people were, literally buying ammo in normal, like 50 round boxes and breaking them up and selling them 10 rounds at a time in Ziploc bags. So the market was a huge demand, like very low supply. The market was just right for it. And so it was like, on top of having like the background that I've got, having this tool available, and then seeing the market demand, it's like, all right, it's very easy to create a product that was well received, And and again too, I'd be lying if I said that our first product was our best product.
Yeah, normally it's not, right?
Ironically, our best selling product now is a part that a customer designed. They paid an engineering fee. We did a custom part for them. And then at the end, the guy pulled the handles. He said he didn't want to commit to a manufacturing contract. I was like, okay, well, this IP is mine now. Yoink. And now it's literally our best selling product. We didn't even design the thing. We went through the nuts and bolts.
Sure.
It wasn't our aesthetic choices, and it's really wild from a manufacturing perspective. But that's the joy of small manufacturing, right? And being a startup is being flexible and agile and adding things or dropping things. Hey, this isn't working. Q2 last year, this didn't work. Q3 last year, this didn't work. Why are we going to do this again in Q4? And so like those kinds of things, like you can be very flexible and agile as a
you can company. Change it around. Right?
I don't have to ask, I don't have to get it cleared. I don't have to do tier 1 engineering investigations. I don't have to do all of these things. Like some of my clients consulting for tier 1 automotive suppliers, getting changes made is painful. And it's got to go downstream, and 25 people have to see it, and everyone has to sign off on it. And it's 5 months after the need was identified, now we're starting to work on it. And like even worse on the federal side, the federal contracting system is horrendous, heinously busted.
Yeah, just for the red tape and the how long, right? Yeah.
Right. And so like one of the challenges is that let's say you yourself, let's say that you're a federal employee and you are a system owner. Let's say you're in charge of a particular like GPS unit or something, right? Like totally random, doesn't really matter. The product doesn't matter. There's some critical change that you need made or some new version of it that you want made. You put out that RFP from the time, the request for proposal, but from the time you put that RFP out into the world, and by the time you get what we call first article back, right? So this is the bid goes out, it gets bid on, it gets selected, it gets approved, goes through all the vetting processes, they prototype everything gets designed up, sent back to you. From RFP to first article acceptance on average is 14 months.
Especially with all
14 months. What?
That's insane.
Yeah, you wonder why you can't get good turnaround on. Yeah, no, it's that explains some stuff actually.
Yeah,
and along with the supply chain issues.
Yeah,
you're looking at things being super delayed. Yeah, that's going to take way longer.
Yep, we've got there's an organization out there called the Defense Logistics Agency, the DLA, and their whole job is to provide the logistics for the DoD. And so what they do is let's say you have some part prototype. Let's say you've got like a tank part or a Humvee part or a helicopter part, some part, arbitrary part, right? And it's manufactured by company X, and company X goes out of business. Well, when you first bought them, you bought enough to sustain that vehicle or that system or that piece of equipment for 10, 15, 20 years. The 20 years is up. You have all the TDPs, you have all of the prints, and you've got all the specifications, but you don't have someone to make this for you anymore. How do you send that out into the world and get somebody to make it for you? Mm-hmm. And so there are companies where their whole job is literally, I mean, all they do is they go online, they hop on the DLA's website, they're vetted through the process, they bid on jobs, they receive jobs, they turn around, they give jobs to subcontractors. We've been a sub for a lot of that stuff. And those are things where it's like, that's really cool and all, but man, that was really expensive for 16 parts.
Yeah. I mean, if you need them, you need them though. Yeah.
Well, that's the thing. So you need 16 of those. Okay, cool. So most manufacturing works really well when you scale, right? You can access and benefit from economies of scale. And so it's challenging when someone needs 12 of something or 5 of something.
Yeah. Oh, definitely.
You know, and so that's where, and depending on the manufacturing technology too, right? That's one of the things that's so nice about additive, right? It's like I can print what I want and I can print one-offs.
Yep.
It might take me 27 hours, but I can print one-offs. Yeah. Totally, it's definitely not a fast technology. It's very flexible. And so this is the hope of this, like, what do they call it? Industry 4.0, right? Is that the combination of traditional and new manufacturing methods will enable us to see greater throughput, particularly on custom or otherwise difficult to manufacture pieces. Think about making a part that has a pipe in pipe. So let's say you've got some sort of fluid whose job it is to transfer heat to some other fluid, right? Like classic air-cooled or water-cooled system. So I can manufacture a pipe. I can manufacture another pipe that fits inside of that pipe. What I can't do is manufacture that in a way that allows it to be parallelized easily and then run one inside of the other so that some sort of heat exchange can happen. Whereas now you can go buy a $1.5 million Mazak, which will not only 3D print in a nitrogen purge chamber using 4 plasma jets to melt titanium together, but then it's also fixed on a base that happens to already sit in a 5-axis milling center. So I can literally stop in the middle of that additive process, machine something out that can't be done in an additive way, or additive is slower.
Yeah, or it's more accurate. Yeah,
printing on it, you know. And so that's where it's like the idea is we're getting closer and closer to the holy grail of manufacturing, which is like product ready, customer ready parts fall out of a machine that raw materials go into.
Yeah. Yeah.
That's awesome.
That is awesome.
It's cool. I mean, that's stuff we're going to put on starships and send into space, right?
Well,
that's you need. I don't know what manufacturing technology you need.
Yeah.
I've got the replicator chamber over here, and all it does is titanium dust.
Yep, it just needs titanium dust. And,
right, and that's
and the same for food. We'll have the same for food products, right?
You know, and so that's the thing is like it's a wild time to be in manufacturing right now because you can go find. Throw a stick, it'll hit a machine shop, right? I mean, there are a lot all over. There's a ton of machine shops. It's part of our base and like our very fundamental industrial base. You know, how do we make rotors? How do we make brake pads? How do you make exhausts? How do you make desks and stands and lamps and dog crates and all the other things that exist out in the world, right? So some very fundamental stuff that exists out there, but those shops are. I won't say they're going away, but they're evolving or dying. If you hop online, there's no shortage of auctions of machine equipment out there from a shop that's closed. And often you get a better deal anyways. I'm going to have the original equipment manufacturer come in and validate it anyways. So I could buy it for 1/3 the price with, 1,000 hours on it. And the expected life cycle of that equipment's 35, 45, 100,000 hours. Like somebody else just spent 6 months trying to figure out they couldn't run a machine shop.
Yeah, I mean, honestly, it's about knowing what you can get, what you need. Sounds like you've done a lot of you've had a lot of experience in your life working for somebody else, working through, like you were saying before, which is great because you were able to come in. And what are some of the things you think you did? I guess well, actually, no, I want to ask a different question. Sorry. Um, we always ask what your favorite tool is, and you're talking about massive tools. And really, I got to know, like, do you have a water jet? Do you have like something else that you're just like, man, this is the thing that's super cool to me, and it's my favorite thing? And what is your favorite tool?
I'd be hesitant to pick one out. So for me, favorite's a weird thing, right? It's a tool. It's a manufacturing methodology or a production methodology.
Okay.
I am far more, again, maybe this is my inner like engineer coming out, but I'm far more concerned about outcomes, right?
Sure.
So it's like you select the methodology that's appropriate to the solution. You can make most of the parts on a mill that you would on a lathe, but that is the slow, difficult, awful way of doing it. And so like those are the things where when people look at manufacturing methodologies, it's like you got to pick something that makes sense. And this is again why additive is so cool. If I had to pick a favorite,
favorite, like
just a favorite.
Who do you
like physical, like in meat space tool that you could pick up?
Sure.
I think the coolest tool is probably a handheld metrology scanner.
And what is that?
Yeah, what is that?
It is a tool that you hold in your hand that lets you scan an object, and it will create a solid model of that tool as you scan it.
Shut the front door.
They
are expensive and awesome.
Yeah. I like the sound effect. Does it sound just like that? Please tell me it sounds just like that.
It's actually super boring. But there are some really cool things. Like some of them are essentially metrology tools where what they're doing is you take an arbitrarily complex part that might be difficult to traditionally measure.
Mm-hmm.
And actually, here's a perfect example. So was in a to be unnamed federal machine shop. Right. So this is a machine shop for one of the military branches. They literally make things for the military. And these are all federal employees, right? So they had a part that was very difficult for someone to inspect. It takes about an hour for someone to accurately inspect this part when it comes off of the line to guarantee that it is within tolerance, within specification. So it takes about an hour to do. And one of the jobs was working up, hey, what's a better way to do this? And so what my solution was to put one of these metrology scanners on the end of a tooled industrial cobot, right, a co-working robot that works in the space with humans, was to put one of these scanners on the tool that literally moves into space. You're going to open this turning center that these parts are coming out of, right? And you're going to stick that tool in there, and then you're just going to run that over and over. And those scanners can take anywhere from 10 to 50,000 measurements a second.
Oh, wow.
So they're very fast and very accurate. I mean, and you got to realize too, we're talking 1/100 of a millimeter accuracy, right? Very accurate. Like some of them are sub-micron accuracy. And so they're very good tools, very cool, very expensive tools. But what happened was I literally say, hey, we put this on here, you run this before you even have that part moved on to your cell, you can already validate that every part that's been run on this was good. And moreover, as it starts to work its way out of tolerance, you can have it alert off of that.
Yeah.
And part off, 500 parts or however many parts you're going to run, take those to inspection and then find that trend over time. Right. So I think maybe that's a super nerdy engineering answer, but I think handheld metrology scanners are probably one of the coolest examples of like that fusion of data and software, but also in meat space. And like you can find them, they're the size of those. You remember the old like gray AT&T brick cell phones?
Yeah.
They basically look like space age versions of those, and they shoot a bunch of different IR and visible spectrum lasers out to measure an object in need space and in real time.
No, that sounds awesome.
That's so cool.
And also the fact that you were able to take it, put it on a robot, and basically just make the process. I mean, it's got to be better. That's got to be way better, not just time saving wise for the hour, but it's got to be like you were saying. You know, you can stop the line and be like, "Hey, let's go back." Probably more accurate, right, than what they were doing before. I don't know what they were doing before, but that's a fantastic example of something like that.
That robot can scan that part in about 2.25 seconds.
Yeah, wow. From an hour and
time saving on that, right? Like
time saving for sure.
Yep.
I mean, it's going to pay for the. It's going to pay for the robot. It's going to pay for the
robot doesn't take time off. Robot doesn't get sick. Like it's one of those things where it's like, man, the robot doesn't get tired. The robot doesn't have a drinking problem. The robot's not going to be going through a rough time at home and just really isn't committed to their work this week. You know,
that's one of the questions I had. And when we started talking about how you are building and engineering for manufacturing, is we hear about the robots, the technology, pretty much getting rid of jobs for people. Just in your time frame, when is that even a possibility? Like when should we hit really worry, or when do we really need to start training our younger generation and kids on how to work these new technologies or building these new technologies?
I mean, now is the time. Let me try to collect my thoughts so this comes out cogent instead of just like stream of consciousness word vomit.
For sure.
You can, what we call LOM, or lights out manufacturing, has been around for 20 years. So lights out manufacturing is you have the system so well tuned and so well set up that I can turn the lights out because the robots don't need it and leave. And that's 20 years old.
Yeah.
So, the difference is it's also really expensive. So, there's a middle ground to it, right? Like,
right.
I can pay, think about it this way. So that cobot, right, for that scanning for that metrology cell, that's a $150,000 scanner on the end of a $200,000 robot. And you had to pay somebody about $1,300 an hour to come program the thing. Right.
And then maintenance.
That guy's not getting paid that, but like that's what they're charging you to come out, set up, deploy, test. Right. So all of that to replace something that you're paying somebody $19 an hour. So how many hours does it take to add up before that cell becomes important? And so this is where what you have to do is you have to make a business case for everything, right? And so what they'll do is they'll look at it and they'll say, okay, cool, here's, $375,000 of stuff. We're going to take 10% over whatever our SME estimates anyways. So now you've got $412,000 worth of stuff. So when you walk that out the door, I've got a $412,000 solution. How many times does 19 go to $412,000? And I've already got that guy hired.
Yeah. And trained.
Right. Now, let's say I only need to make 1,000 of those parts a year. Okay, well, how long does it take for that cost savings to show up? Mm-hmm. And so those business cases write themselves, but they're still hyper contextual to the business. The real challenge, like so in the federal space, for instance, it's just almost impossible to fire people. Like that drives business case pretty easily. They ultimately didn't wind up going with my solution. Why? Because that's expensive and I got to buy all that stuff. And now I have to have a guy that knows how to speak robot who's going to come in and tune that. But I've also walked into other shops, sadly, that have already purchased that equipment, but don't have anyone that can sling mean enough G code to program that robot. So this is where it's, when I look at, if I put my money on the table, I think that this industry 4.0, this fourth industrial revolution, right, that we're going through, it's as important as you want it to be. Like there's still going to be welder fabricators out there. I will have lived the breadth of my life and died, and could have lived the breadth of my life and died again. And there's going to be somebody out there with a TIG torch putting stuff together.
Oh, for sure.
Because there's still going to be a shop. There's still going to be somebody who's like, this is the equipment I have, and we can still make very valuable, very profitable things for people. And that's where, as the business, like, you got to make the business case, right? How does this impact our value stream? Does it really matter whether the robot makes this or not? And so I think if I were to pick a time to answer your question directly, the time is now to prepare for those things. I don't know if you look around and see how many, blacksmiths are there.
Yep.
Right. Very few.
We time travel, 300 years in the past, how many are around now? Like, people know it's like welding. Welding is a 19th century invention. Like the first welder, literally a Lincoln Electric horse-drawn buggy. Like,
that's cool.
It's not a new technology.
Yeah.
It's just not, But riveting was so popular and so easy that people continued to use hot rivets forever, even though it is a demonstrably inferior technology. I mean, it took 30, 40, 50 years for us to even be able to demonstrate that it was better than riveting. Like, it took us that long to have a strong enough understanding of strengths and materials and actually be able to gather data from stress testing. I mean, like, wow. Think about, like, how far back in the past is Kitty Hawk?
Not really that far when you really think about it.
Right. Yeah. And realize that landing on the moon is closer to Kitty Hawk than landing on the moon is to today.
Yeah. That's when you think about stuff like that.
Right.
Oh man, it blows your mind.
Yeah.
However, I will say this: we're a lot faster at getting to, like, with our knowledge that we have now and these machines that we have now. Things are turning over faster. We can test things faster. So I do think that. I think you're right on the money with all your predictions there. But I also am going to say too, more to that line. You just said there were enough people that could sling G code. Right. So now, instead of learning how to put rivets in something, learn how to do G code. Right. And then that's exactly our workforce now is people who now know how to program these machines, do maintenance on the machines, do maintenance on all the other, like the machines that are giving the machines power. Right. All those things are stuff we need.
That's the challenge, right? Like, philosophically, it should be a good thing. Like, having your job automated away should be a good thing. It should be a good thing. And because of the way, like, we structure our economy and our society, it's usually not.
Well, we've talked about this on here for many different times. But one of the big things that I'd love to go back to is if we can automate everything or automate most things, right? Then what that allows us to do is it lets us do the things we're passionate about, right? So we don't have to have somebody as a blacksmith. We don't have to have somebody doing these things, these jobs that really aren't very, creative at all.
Do things that you love.
Right, you can do something that you love, and there's people who are all about automating everything. Yeah. So then the village of people who is there with the automation of everything can literally do anything they want to do, and they're going to do well at that thing too.
100%. And there's this really weird thing. So, like, think about everyone that you know that has some sort of like think about anyone that is born wealthy, right? Anyone who comes from a wealthy family, anybody who on a fundamental level does not actually have to get an education and go into the workforce, right? Almost every single one of those people, without fail, reverts to art of some sort, right? Sport is art, right? Sure. Like, martial arts are art.
Or music. Right? There's a lot of musicians that come from that.
Art, right? Singing, dancing, the production of things, right? Like, they do things that they're passionate about and that they enjoy. And I think it says something very fundamental about us as humans, where if all of our day-to-day financial needs are taken care of, that most of us revert to making or consuming art.
Yeah.
And I think, honestly, like, when we talk about the maker movement, it's democratizing access to that level of creativity and enjoyment, right? So that I can look at a thing that I like, that someone else maybe drew or created or whatever, pick any IP from any, right? Like, oh, I want to be a space marine. Okay, cool. Like, that's awesome IP. That's really fun. Like, Games Workshop has a really cool universe to play around in. What awesome set pieces, right? And so I don't have to be independently wealthy to have at least some free time to go pursue those things and make those things. I can make those costumes, I can go to those conventions, and I can enjoy them even as somebody on a budget, It's like,
or you can play the game in a game shop. Yeah.
Tells you, right? The fact that people do that tells you like there's still a yearning need for this art out there in the world.
Totally.
That stuff. And it's one of those things that I think is just very frustrating that people think that like if the goal of automation is to put everybody out of a job and everyone's going to wind up jobless, what are we all going to do? And I'm like, whatever the hell you want.
Yeah.
Like that's the goal, like, man, if I could take your drudgery and automate it, like you're welcome.
There's a lot of
getting a paycheck. So we gotta work that out. But also like, you don't have to stand there at a pick and place and like pack boxes. Like that's mindless work. One of the fundamental tasks of robotics is to do things that we call dirty, dull, or dangerous, right? You want to automate things away that are dirty, right, dull, or dangerous. Like that is very A to B. Like, man, robots are really good at these things. They're not going to go try to find another job. They're just going to execute the task at hand,
right?
Until you tell it not to, or it breaks down, right? And like, so I think all those things that are dirty, dull, or dangerous, we should automate away. Like I got a guy, and it's not always physical. That's the wild part. It's not always physical. I had a guy whose job I automated, and he was so concerned. He was so worried. So I'm a client, a light manufacturer, right? They were into, what do they make? Architectural panels, right? Think fancy plywood, right?
Okay.
So there was a guy there who was terrified. He's like, all right, but you're going to automate my job away, right? And I'm like, I don't even know, man. Like, we're still scoping this. So hopeful, like, I don't know, and I found out. So when we got to it, we were doing an assessment. I was doing an analysis, and I found out like that guy's whole job was he would receive a spreadsheet from the sales department, and he would receive a spreadsheet from the production floor, and he would copy numbers from one spreadsheet to another manually.
Yeah.
Damn.
That's pretty simple to automate.
Like, we automated shit like that way in the 80s. So, it's one of those things. And I told him, like, hey, so I know you're worried about this, but like, I have to say, man, this is like an afternoon's worth of scripting in Visual Basic. Like, I'll even put the edge case and the error handling in there. Like, all you'll have to do is open the spreadsheet up and push a button, and it will do everything that used to take you 40 hours to do. And then all you have to do now is verify it. All right, so go verify it. Go look at it. Make sure it did its job right. It didn't like mash up some of your analysis. It made the charts that you wanted, right? Like, and so come to find out, that guy actually had a background in industrial automation. And I was like, cool. Well, hey, why don't you come upstairs and talk to the team who's doing some of this stuff, right? In the long run, that guy wound up helping them start creating new production or do manufacturing cells for their shearing and pressing line instead of manually transferring stuff from one spreadsheet to another. And I'm like, wouldn't you rather have been doing this for the last 10 years instead of like just spreadsheet like?
Well, you probably did, but the hard part is sometimes with innovation in general, as you being an engineer, as in consulting, it's hard telling the other people that are hiring you, if you're the worker, that they're doing it wrong.
Yeah.
Well, yeah.
It's a challenge. Well, and definitely there's something to be said to the executive listening to somebody they're paying, $500 an hour to do this assessment. It just slaps differently, I guess.
Oh, totally.
Totally.
The kids are saying now, like, I don't know, I'm not cool enough, but
no,
those things,
you're right. Yeah,
different. Perfect example. I had a CIO at another client organization, telecom firm, and a buddy of mine. He's a CIO. He had a plan for an infrastructure upgrade. CEO listened to it, didn't follow through with it. He had me fly out and paid me more than I've ever been paid by the hour before. I paid $2,000 an hour to pitch a 2-hour idea using the slide deck that he used.
Ooh.
So the CEO would listen.
Yep.
And you know what? They implemented it 4 weeks later. Why? Because he had to burn like $6,000 to hear it. That's the weird stuff. Like that's the weird where I'm like, you just had to hear this from someone else. Like that guy's in the C-suite. He is on your team. Like, and so that's a silly example, but like, I mean, maybe like with this guy, that's one of the things that happened. But like, I was super happy that I was able to free him from that with automation. You know, it's like, hey, here is a fantastic opportunity for you to go do something that you enjoy. Now, instead of doing what I can do in software in 2 hours, like, and never have to do again, like you can go do more impactful things for the business. And I can make a business case for that every day. You know, now you've got this worker back 30 hours a week to go solve any other problem. And maybe they can, maybe they can't. But if they can't, then let's train them and then retool them to do something else. Turns out this guy already had a background in automation. Mm-hmm. So I'm like, especially if you had a background in automation, I found that super wild. I'm like, you have a background in automation and you still did spreadsheets for me.
Yeah, I was thinking myself, he had to have it automated already, probably.
You're killing me, bro.
Like, come on.
Yeah.
Yeah.
Nope, because the fear was that he would work himself out of a job.
He wouldn't have a job, so he would automate it, and then he'd be like, "Oh no, I don't." Oh, that's
and this was a guy like that plant would have fallen apart without him doing that.
Yeah. So
like he was the point of articulation between sales, right, client facing, and production, right, which is service and product fulfillment.
That's some Office Space stuff right there, right?
It literally it is peak TPS report.
Yeah, it was like it was. we talked to the end user. So we gotta get. So you're the Bobs, is what you're saying. You're Bob and Bob.
Yeah, that's. I guess that's.
Do you have a second Cameron that comes in to Office Space?
He's got straight shooter with upper management written all over him.
Yeah, exactly. Oh man.
Well, and so that's the joy of engineering, right? It's like looking at like a solution set, problem, then iterating through problems to iterating through solutions, right? To make sure that they solve all the requirements, right? That they meet all the requirements the client has and solve all the problems that they have, and you reach that desired outcome or end state. And like in that instance, the whole project, the reason I started that engagement was literally to find places to save them money.
Yeah,
that was the only request from that particular client engagement. Was they were like, I know we're bleeding cash, and I'd like to find places that we can automate things to free up some money, either free up some labor or free up some payroll. And I was like, well, I'm happy to help you with that first one. The second one sounds a little evil. Like that's that's where I have to try to not be a piece of crap and help him. But like that with that guy, I'm like, hey man, I'm not going to out you real bad, but I'm going to tell you but it's a Tuesday. I'm going to have this automated by COB tomorrow. So like, what can I help you? Like, what else can you do? And then turns out I have the super applicable skill.
Right.
And so
that's good. I'm glad you were there to do that.
Like, yeah, I mean, maybe the horse-drawn carriage is going out of style and everybody's going to be driving these newfangled automobiles. Okay, well, I guess it's a good time to go back to trade school and become a mechanic, right? Or like whatever the thing is. Now it's all software, right? Everybody wants to do software. Yeah. Software that, we'll do it in software. I'm like, there's still lots of work to be done in meat space.
I love that you call it meat space. I don't think I've ever heard anybody call it that before. And you've said
it's one of those ones where all the meat lives, right?
Yeah, no, it makes sense. It makes perfect sense. Yeah,
it's one of those things that like one of my professors had this really poignant saying. He was like, you can't eat code. You just can't. Code has fed a lot of people.
Yeah, but
you can't eat code. There's still going to be somebody somewhere flipping a burger or making a taco.
Or farming.
It's like whether a dude does it or whether a robot does it doesn't really matter. But like that food had to be grown somewhere. It has to be processed and reprocessed and whatever it is you're going to eat. And so like that's where it's like finding those places where in this industry 4.0, people can still have meaningful careers, meaningful employment, at least until we change our economy to where we don't have to work. Right, which it becomes optional. Participation is optional. Your value as a person is not based on whatever value you can provide to some revenue generating organization, right? Like fundamentally though, like I look at it now. So like I have a kid, right? I have a 12-year-old, and they can code, they've made parts on a mill, they can weld. Like all of these skills, right? And they still make badass art, So it's like those kinds of things where I'm like, hey, I want you to have an equal amount of breadth. And then when you find something you really like, then go deep, like then achieve your depth, And it's like, I think that like we'd be better off as a society if instead of forcing kids to go through high school, right, we have them basically at that point start, all right, your junior year or your freshman year, your first year of high school, right? You are going to go job shadow people. Here's a big old 200, 300 some jobs.
For sure.
You're going to go job shadow these people. And not for 10 minutes, right? Not for a day.
No,
you're going to go spend a week with that pipe fitter. You're going to go spend a week with a mechanic. And you're going to actually help them, right? Even if you're just going to stand there and hold the flashlight and get cussed at. You are going to be there and do the thing and watch the thing and like just see like, oh, this might seem really cool on paper, but your day-to-day job actually kind of sucks.
Oh yeah, totally. Like, and so
then based on that, you choose a trajectory, and we don't set kids up to where it's like this is what you're going to do for the rest of your life. No, this is what you're going to do for the next 5 years.
Or even less than that.
Plan that like. Your life can be in these short segments and you can change things over time. Like just because you went to school to do something, to be a welder, if welding and fabrication jobs go out of style somehow, which I don't anticipate, right? Like, all right, cool. Well, now you can do what's the next 5 years. All right, you're going to go back. You're going to learn to code. You can write some code now. Cool. You don't like writing code. You can find some service industry that you're particularly passionate about, or you can do art for a living, or you can do like constantly reinventing yourself is not always a bad thing. And I think that for millennials like myself, like we looked at our parents and our parents had these like capital C careers and like, that's what you are. You are what you do. And you do that until you're done. And then you retire and you go do something else. And we don't know what that is yet, but that's 30 years from now. And I'm like, that seems like a crap deal to me. I'm like, how about this? You have the ability to feed yourself and you develop some job skills that'll always enable you to have a job and everything else is extra.
Sure.
No,
like,
that's learn how to
exactly.
That's how skills and abilities are honed. And actually, I find that a lot of people end up doing the thing that they were trained to do, and then for a little while, and then they find something they're actually passionate about because when you picked what you were getting be trained on, you were young usually, so then you end up doing whatever it is that you're actually passionate about. You usually can use the skills are transferable, right? In the same way that like you want to learn how to do something, most time the way you learn how to do things is because you want the end result. So then you learn the thing, you learn the skill to get the end result. And I see that a decent amount.
I mean, the journey is there, right? So I mean, like this is your practice life. Like you get one playthrough and there's no save games.
Totally. So, absolutely. It's good to to know.
Do something fun, do something you enjoy. And when you stop enjoying it, not when you hit adversity, not when you hit challenge or struggle, like those things are important. And I hate to say like, oh, they build character, but they overcome adversity. Like if you stop every time you try something, like everything that's really meaningful in life is hard to do, perhaps with the exception of making children, right? Like literally one of those things that like, hey, do you know how many people have accidentally ordered a pizza?
Sure.
You know how many people wind up with kids?
Yeah.
Right?
No,
hard things are typically meaningful. The adversity, the challenge. Like it's not to say that like there's like all this like noble suffering. Like the reward for poverty is usually more poverty. But like things that are hard, you see people try things, and as soon as it gets hard, they stop. And this is one of the things I find really cool about the maker movement is like you see people like, and they'll try a skill. Like wood turning is a perfect example. I mean, turning wood is simultaneously the easiest and hardest thing I think most people can do, right? You've got a spinning chunk of dead tree in front of you. And depending on how much pressure you apply in that tool post, you either come out with like this really beautiful table leg or you get hit in the face,
Right.
Yeah.
And
Right.
Normally it's you get hit in the face a couple of times.
Yeah, and then you get
and then you learn how to make the table leg.
Right.
Right.
And
Or
if I could talk to like brand new makers, like what I like to tell people is I'm like, have some time, give yourself some time to fail at a thing.
Oh, for
I
sure.
know that always sounds so trite, and I've heard it myself. I'm always kind of resentful of it, but like I find now that I'm not at the beginning of my career anymore, and I like leave yourself some room to make mistakes. You know, like there's nobody got it in one usually. You know, and it's the repeated application of effort, not skill. The repeated application of effort that builds competence, that builds achievement. Like I look back at some of the things that I did as a consultant. I'm like, that was a real crap solution. Like, I don't know why you would recommend that. There are these other like 15 things you could have done better, you know? And it's like, when I've had systems, I've had parts I've made, I've had stuff where I'm like, man, you just chose the hardest way to do that. And then you doubled down on it when someone pointed out you were doing it the hard way.
Yeah.
Because nothing says fun like throwing good money after bad. Where it's like, I'm committed to making this.
That's part of the learning part of it, right? It's part of being young and not understanding exactly how that goes, not learning from your failures, which is what some of that is. But hey, we are at right at time, and Cameron, I gotta have you back on here. Like this, you've been super interesting to talk to, and honestly.
I have so many more questions.
Yeah. Let's say we have all these questions.
Well, thanks, guys. I really appreciate it. It was fun being on here, and I'm happy to come back whenever.
This is the other thing I gotta say, Cameron. You're such a nice guy, and if I couldn't tell that you're a nice guy, I'd think you were Destro.
All right, I feel you.
And for people who don't know, Destro is like one of Kofi's favorite characters from G.I. Joe, and we talk about him all the time. He had to get the Destro comment in there.
It wouldn't have been an episode without a Destro comment.
I would be lying if I said that he wasn't a role model.
Yeah.
So knowing's half the battle. And the other half is red lasers.
We know the other half. Yep.
That's the thing.
So, and I also got to ask for a lot of people because there's a pet in this one. What's the dog's name?
Oh, Puppers. Hey, come here, Bubba. Come here.
We gotta see the
Abrams. He's a full-blooded German Shepherd. Some friends of ours had, and then they weren't able to keep him because leases are awful. But can you give everybody a little bit? Give me a little bit. All right, thank you. All right, go down. Go on.
So, what's the dog's name?
Abrams. Like the tank.
Like tank.
Yeah.
Okay. Well, hey, Cameron. Like I said, we do have to have you back on.
Right.
No, it's been super fun. I loved talking about the automation and we covered some things on this show that we've kind of delved into a little bit with other people, but not nearly as much as this, which is great. And I thank you for that. But yeah, where can we work with you? Can you tell us again? What do you have if somebody saw this and man, I need to work with this guy more, where can we find you?
So until recently I was on the board at Blooming Labs. It is Indiana's first makerspace. It's in Bloomington, Indiana. You still find me there sometimes. You can also find me at PantherWorks. That's pantherworks.com. Works is with an E, WERKS. You can shoot us an email there, team@pantherworks.com. Just hit me up. I'm happy to work with you guys, and I'm happy to share any tips. Like I said, I know it might be outside of the traditional vein of makers, but I've got a strong background in fabrication and creation, and it's making is just what makers do, much like engineering, so it can be as broad and as deep as you want it to be. So hit me up. Who knows? Maybe I can help you. Maybe I can give you some advice. Maybe not. Give advice for a living, so I can probably help. But
well, cool. Okay, Kofi, go next.
Well, I'm Patrick Kofi Austin, content creator, marketing person for Mojo Up Marketing Media. If you ever need to get a hold of me, you just find me on LinkedIn at Patrick Kofi Austin. And over to you, James.
I'm just admiring that nice room you're in, man. I'm jealous. But yeah, I'm James Wolfgar, and I'm down here at the Makerspace in Lafayette, Indiana. We're MatchBOX Makerspace. We are holding a couple events I got to talk about. There's going to be a MatchBOX block party at the end of the month on the 23rd. It's on this Saturday. Actually, it's on the 25th. I misspoke. So on the 25th of this month, we're going to be doing a block party. It's open to everybody. You do have to buy tickets, but the tickets go toward funding our not-for-profit co-working space. And then a month later, on the 23rd of July, we're going to be doing the Makers Showcase. So that'll be another event here, and it's all about makers in the community. And we have a couple of people coming in from even out of state to that too. So there's 2 events coming up, both the 25th of this month and the 23rd of next month. If you have any questions or you want to know more about it, you can go on to our MatchBOX website. And if you have any other questions, or if you want to be on the show, or you know somebody that you want to have me reach out to be on the show, please let me know. My email is james@matchboxstudio.org. All right. Thanks a lot. And I'll see you guys in 2 weeks for another Maker Monday.